Hello and welcome to Mr. Tompkins EdTech and a brand new series of videos aimed at helping you prepare for your GCSE mathematics exams. In this series I'll be giving a complete walkthrough of the GCSE mathematics practice papers to help you prepare for your exams this summer. Now there are not so many of these and you don't want to squander them, so make sure you try the paper yourself first before you look at these solutions. This particular paper is OCR November 2020, Paper 1, Foundation Tier. Check the front cover of your paper to make sure it's the same one. If it's not, have a look through the playlist linked above, which includes all the GCSE Maths video walkthroughs I've recorded so far. I'm busy recording all of the GCSE practice papers, so if the one you're looking for isn't there already, why not subscribe by clicking the big red button below and check back in a few days. Don't forget to click on the bell so that you'll get a notification when I upload the next paper. I'll put timestamps in the description below, so you can choose to watch the whole thing through, or you can click on the timestamp and jump to the particular question you need help with. If you have a question, check the comments below, as someone else might have already asked the same thing. If it's a new question, leave it in the comments and I will try and answer all of them as soon as I can. Don't forget to mention which question on the paper you're referring to and try and be as specific as possible. Finally, if this video helps you with your revision, please give it a thumbs up. It will really help me out, and why not share the link with your friends, because they might need a helping hand too. Okay, let's get into it. Welcome along to another past paper walkthrough. Today we're going to be looking at OCR November 2020 series. Let's get cracking. Question 1. Reese asked some friends what type of program they watch most on television. The bar chart shows some of his results. So we can see on the left hand side coming up here we've got frequency, and underneath we've got type of program, and we've got comedy, sports, nature, film, news and soaps. Question A says 10 people answered film. Complete the bar chart to show this information. Okay, so you can see on film it's actually missing the bar at the moment. So we're going to fill this one in. Okay, so 10, where's 10 on the scale? Well, it's going up in twos, isn't it? 2, 4, 6, 8, 10. Draw the top of the bar first, I think. And then just spin it around and draw the sides on. Bar chart should have a little gap between the bars. They shouldn't touch each other. Okay, and they're kind of shaded, so I might just kind of shade it in a little bit. There we go. Good. Did that one right. So the next part says complete these sentences. Blankety blank was chosen by the most people. Well, the most people is this bar on the end here, isn't it? This one. That's the most, which is soaps. Blankety blank people chose news. So how many people chose news? Well, news is this bar here, and you can see if I read across from the top of the bar, that's 7, isn't it? Okay, so 7 people chose news. And then finally, blankety blank fewer people chose nature than comedy. So fewer. So this is the comedy bar, and here is the nature. So the difference then between the two is like this amount then, isn't it? It's one bar subtract the other, which is 3 people. So 3. Okay, question 2a, reflect the triangle in the mirror line. Okay, so I think with reflection the easiest thing to do is to reflect the points first. So take each point on your shape. Let's take this one here, and then see how far away it is from the mirror line. That's like 1 square to the mirror line. So its mirror image is going to be 1 square on the opposite side. It's going to be there. Similarly, this point here is 1 square away from the mirror line, so its image is going to be 1 the other side, like that. And then finally this one at the tip here. Now that's actually 1, 2, 3, 4 units away. So its mirror image point is going to be over there. Now once you've got your vertices or corners of the shape, you can then join them up with a ruler. Okay, so reflect the points, don't try to reflect the lines. Because normally when students try and reflect the lines, they go a bit wonky on these. Okay, just tidy that up a little bit. Get rid of those, get rid of those. Okay, so there we go, that's my reflection. Oh, went a bit too far, they got rid of that point. Right, let's move on. Part B says rotate the triangle 90 degrees clockwise about the point P. Now, with rotation, I do recommend that you use tracing paper. If they don't give you a sheet of tracing paper in the exam, you can just stick your hand up and ask one from the invigilators, they'll bring one over. Easiest way to do it, really. So just put your tracing paper over the top of the shape. And then just mark the corners. I don't usually bother drawing the lines. You can join them up if you want, or just simply mark where the corners are. The other thing I like to do is I like to put a little cross on the point where we're rotating around, because that helps me work out when I've done 90 degrees. So when I turn this thing around, because I've got a cross on it, when the cross lines up again on your grid, then you know you've gone 90 degrees. Okay, then once you've done that, you can just kind of stick your pen underneath the tracing paper and mark out the points, and then you can remove your tracing paper entirely and then join them up again. So again, we're rotating and we're finding the corners or the vertices. We're not trying to rotate the lines. Okay, once we know where the vertices are, we can just join them up afterwards. Okay, 90 degrees clockwise about the point P. Question 3, work out the volume of this cuboid. Okay, well the formula for the volume of a cuboid is just length times width times height, isn't it? Okay, so the length of my cuboid is going to be this one, my width of my cuboid is going to be this one, and my height is going to be this one here. I'm just going to sub those three values in. So then that is 7 times 2 times 5. 7 2s are 14 times 5, that's 70, isn't it? 70 what? So that's centimeters times centimeters times centimeters. That is centimeters cubed. Okay, so 70 centimeters cubed. Question 4a, write 2% as a decimal. Well, percent, if you remember, means per 100 or out of 100. So 2% is the same thing as 2 100ths. And then if you think about decimal numbers, you've got the decimal point and the first digit is tens, and then the second unit is hundredths, isn't it, after the decimal point. So 2% is going to be 0.02. Okay, another way of just remembering that is this is like the tens and this is the units of your percentage. Okay, so you can just take your percentage out of 100 and write the tens where the yellow one is and the units where the green one is, and job's good. Right, B, write 11 over 20 as a percentage. 11/20. So now I just said that percentage is a kind of out of 100, a fraction over 100. So if we can take this fraction and rewrite it as a percentage like this, just by times and top and bottom by 5, that's going to make it into a percentage, isn't it? It's going to be out of 100. So 11 5s is 55, so that makes it 55%. Okay. Now you can also just do this on your calculator. You can just type in 11 divided by 20 times by 100 into your calculator. 11 divided by 20 times by 100, and that's going to give you the percentage as well. Okay, it's a calculator paper, so you can do it with a calculator, or it's not really that hard to do it manually. Question 5, use one of the symbols less than, equals or greater than to make each statement true. Which one is bigger, 0.7 or 2/3? Now if you type in 2 divided by 3 into your calculator, you're going to get 0.6, either with a dot on it, or it might just be 0.6666666 as far as your display will show, and then a 7. Regardless, you can see if I compare this 7 here with this 6, then this one is bigger, isn't it? Okay. Yeah, so 0.7 is bigger than 2/3. But the second one, now these two bits are the same, so that bit is the same as that bit. So the thing we're going to be comparing is the next biggest part, which is this digit here. We're going to compare the 0 with the 5, and we can see the 5 is bigger, so the symbol is going to go that way around. Question 6. A bag contains 12 counters. 6 are red, 4 are blue, and 2 are yellow. A counter is taken from the bag at random. Mark with an arrow the probability that the counter is red. Okay, well, probability is successful outcomes divided by total outcomes, isn't it? That's the definition of what probability is. So what's the probability of getting red then? So the probability of red, that's going to be, how many red counters are there? There are 6 red counters. There are a total of 12 counters. So 6 out of 12, which is the same thing as a half, isn't it, or 0.5. Okay, so on my scale here, half is going to be in the middle, isn't it? So I'm going to point my arrow in the middle of the diagram there. Okay, that's going to be half. So, kind of missed it. Let me just draw that again. Okay, so in the middle, half. What about yellow? So probability of yellow then. How many yellow counters are there? There are 2 out of a total of 12, which is the same thing as 1/6. Now, I don't know if you noticed, but there are 6 divisions here. 1, 2, 3, 4, 5, 6. So 1/6 is going to be one of those divisions along then, isn't it? So it's going to be here. That's going to be 1/6. So the probability of yellow is going to be there. Green, probability of green. Well, I didn't see green on the list. There are actually 0 green, so you've got 0 chance out of 6 to select green, which is just 0, and 0 on my number line is here. Okay, so it's impossible. Then no greens. Question 7a, divide 72 in the ratio of 4:5. Okay, so when we're dividing into a ratio, the first thing we need to know is the number of shares altogether. So we're dividing 72 into 4 shares and 5 shares, and 4 plus 5 gives me a total of 9 shares. So the next step is to work out what the value of those shares are. So what is the value of 1 share? Well, if I take 72 and I divide it by the number of shares, it will tell me the value of 1 share. So 9 times 8 is 72. So 72 divided by 9 is going to be 8. So each share is going to be a value 8. Okay. So then what we can do is we can take our ratio of 4:5 and we can scale it up by a factor of 8 because each share is worth 8. So if I've got 4 shares, it's going to be 4 lots of 8s. 4 8s is 32. And if I've got 5 shares, that's 5 lots of 8. So that gives me 40 altogether. So how much do they get? They get 32 and 40. 32 and 40. Okay. In 1 year, Clara and Dave borrowed books from the library in the ratio of 3:7. Dave borrowed 35 books. Work out the number of books borrowed by Clara. Okay. So we've got Clara to Dave, and they're in the ratio of books borrowed 3:7. Okay. Now we're told that Dave borrowed 35 books. So I'm going to write that 35 under the Dave column, and then I want to work out, well, what is Clara's then. Okay. Now the way we can do that is we can say, well, if I've got 3:7, what do I have to multiply the 7 by to get 35? I'd have to times that by a factor of 5. Okay, so if I take 7 and times it by 5, I'm going to get 35. And I have to do that on the other side as well. So if I do the same thing on this side, times it by 5, then 3 times 5 is going to give me 15. And that is the answer that we're looking for. So Clara borrowed 15 books. Question 8. Yogurts are packed in trays. Each tray holds 12 yogurts. What's the smallest number of trays needed to pack 460 yogurts? Okay, so number of trays required is just a straightforward division, isn't it? Number of trays is going to be the total number of yogurts, 460. We're going to have to divide that by the number of yogurts that fit in one tray, which is 12. So what's 460 divided by 12? Let me find my calculator. So 460 divided by 12, that comes out to be 38.3 reoccurring, which I'm just going to round off to 38.3 when I write it down. Now, normally we want to know the smallest number of trays, don't we? So 38.3 normally rounds down to 38, doesn't it? But we need to fit all these 460 yogurts into a tray. So once we've filled up 38 trays, we've still got a few left over that need to go somewhere, so they're going to have to go into another tray, aren't they? So we're going to round this off upwards, in this case up to 39. Okay, so the smallest number of trays needed to pack 460 yogurts is going to be 39 trays. Question 9, 59 families are asked whether they have a cat, which is denoted by C, or a dog, which is denoted by D. 26 only have a cat, 14 only have a dog, 11 have both a cat and a dog. Show this information on the Venn diagram. Okay, I like to start in the middle. It doesn't really matter in this case, but 11 have both a cat and a dog, so that can go in this area here then, can't it? I'm going to just write the number of 11 in there. Okay, and then what about the other two statements? 14 only have a dog, so 14 only have a dog is outside the cat circle, so it's going to be this bit over here, isn't it? This is only dog. Okay, so that is going to be 14. Okay, and then we got a statement 26 only have a cat. So cat only is going to be this part of my Venn diagram over here. So that is 26. Okay. Now the only other bit of information we've got is this bit up here. 59 families were asked whether they have a cat or a dog. Okay, now how many have we accounted for so far? We've got 26, 11 and 14. What does that add up to? To 26 plus 11 plus 14. That comes to 51. Okay, so 51 is not the same thing as 59. 59 subtract 51 leaves me with 8 people to put in. Now, if those families don't have a cat or a dog, then those 8 families are going to have to be out here then, aren't they? Okay, so how many of the families do not have a cat or a dog? The answer is 8. Part 2 said write your answer in the correct place in the Venn diagram. Well, I already did that because it looked proper to me. That's what I'd have done anyway. And then finally it says one of the families is chosen at random. Write down the probability that they have a dog. Now remember I said earlier that probability is successful outcomes divided by total outcomes. And in this case, how many successful outcomes are there? So probability that the family chose a dog is how many doggy families were there. Okay, I know there were 59 altogether. If you go back and have a look at the Venn diagram, you'll see that the dog section then is going to be everyone inside the D area here. So it's both the 11 and the 14, isn't it? So that gives me a total of 25 dog-loving families. So I'm going to write that on the top. So there are 25 successful outcomes because there are 25 doggy families, and there are a total of 59 families altogether. So the probability is just 25 over 59. Question 10. Nadia thinks of a number. She finds the square root of and then divides it by 5. Her answer is 20. What is the number she was thinking of? Now, this question is actually an algebra question because the thing that I want, the thing that comes first in the question we don't know the value of, do we? Nadia thinks of a number and she doesn't tell me what that number is. So we're going to use a bit of algebra. We're going to call it x. So Nadia thinks of a number, okay, and that gives me the value x. So I'm going to write down x, okay. Okay, and then it says she finds the square root. So how do you find the square root? You do this, don't you? Write the square root symbol. So that's the next thing that we did. And then divides it by 5. Okay, so then we're going to divide by 5, which we write like that. Okay, and then the answer is 20. So that means that is equal to 20. Okay, so just by reading through the text and kind of piecing it together, what we formed is a equation in x. Okay, now to find the value of x, we need to kind of unwind it, don't we? We need to solve the equation. We need to move all the other bits to the other side. So just leave us with x by itself. Now we do this with inverse operations. So we kind of unwind it. So think about BIDMAS. BIDMAS. Normally this is the order of operations. So if you knew what x is, you would do it in this order, wouldn't you? You do the index first, which is the root, and then you do the division second. So you do the index first, which is taking the square root, and then you would do the division, and that would leave you with the answer of 20. Now when you are solving an equation, you have to kind of work through BIDMAS backwards. Okay, so the way you approach this is that you go in the opposite order of BIDMAS when you're unwinding or solving an equation. Okay, so rather than dealing with the index first, or the root in this case, I'm going to deal with the division. Now what we do with equations is the opposite of the thing, to kind of reverse it, don't we, to unwind it. So the opposite of dividing by 5 is timesing by 5. So I'm going to times this side by 5, but to make sure it continues to balance, I'm also going to times this side by 5 as well. Now this 5 cancels with this 5, and that is going to leave me with just root x on the left. Okay, now on the right hand side I've got 20 times 5. 20 times 5 is 100. Okay, and then what do we do? So now I've got root x is equal to 100. Now I want x is equal to 100. So we have to kind of do the opposite of square rooting. Now the opposite of square rooting is actually squaring. Okay, if you square a square root, you get your original number back. Okay, so if I square both sides, what do I get? So the square root of x squared is going to leave me with just x, and the square of 100, what's 100 squared? Tap that into the calculator maybe, or if you know how to do like count zeros, it's going to be that, isn't it? 10,000. Okay, so x is 10,000. Why did Nadia think of 10,000? Question 11, the scale on a map is 1 to 50,000. How many kilometers on the ground are represented by 8 centimeters on the map? Okay, now I'm going to start off with this question. I'm going to look at it the same way as I did with the ratio question earlier. These map scales are just ratios, aren't they? 1 to 50,000. Okay, now if you remember what I did is then I thought, well, I write the 8 here underneath the 1, and then I work out, well, what do I have to do with 1 to get 8? Well, I have to just times it by 8, don't I? Okay, now if I do the same thing to this side, what is 50,000 times 8? Times 8, that comes out to be 400,000. Okay, so that means that 8 centimeters in real on the map is going to be represented by 400,000 centimeters in reality. Okay, but we don't want it in centimeters. We're asked how many kilometers it is. Okay, so what is 400,000 centimeters in kilometers? Okay, well, first off, I know that there are 100 centimeters in 1 meter. Okay, so if I take this 400,000, I divide it by 100, I'm going to get it in meters, aren't I? So dividing by 100 is basically scratching those two zeros off the end. So it's going to be 4,000 meters. Okay, and I know that 1,000 meters is the same thing as 1 kilometer. Okay, so if I divide this again, if I take 4,000 meters and I divide it by 1,000, I'll get kilometers. So dividing by 1,000, I can scratch those 3 zeros off. It's just going to leave me with 4, isn't it? 4 kilometers. Question 12a, a train is traveling with a velocity of 15 meters per second. It then accelerates at 0.5 meters per second squared for 6 seconds. Use the formula v equals u plus at to calculate the velocity of the train after 6 seconds. Okay. Now v equals u plus at is quite a famous formula. V is final velocity, U is initial velocity, A is acceleration, and T is time. Okay, now what have we been given? We have been given a train is traveling with a velocity of 15 meters per second. Okay, so that is my initial or starting velocity, isn't it? So that is my u value. That's 15 meters per second. Okay, then I've been given this value, the acceleration of 0.5 meters per second. So that is my a value. That's 0.5 meters per second squared. And then this here, 6 seconds, that must be time then, mustn't it? So that is equal to 6 seconds. Okay, so now I know what's what, I can shove it into the formula. So v equals u plus at. Well, u is 15, a is 0.5, and t is 6. So I got 15 plus 0.5 times 6. Well, 0.5 times 6, half of 6 is 3. 3 plus 15, that is 18. And it's going to be measured in the same units as initial velocity, meters per second. Now part B says rearrange the formula v equals u plus at to make a the subject. Okay, so now we did solve an equation before, and I said to you then that you use BIDMAS backwards, and you bib. Why don't I write bib? That we use BIDMAS backwards. Okay. Now in this case, I've got an addition and I've got a multiplication, haven't I? I've got an addition here, the plus. So I'm doing some addition and I'm also doing some multiplication. So normally I would do, if I was evaluating like I did earlier, I times this bit at the end first, didn't I? Okay, I multiplied that bit first, and then I added it onto the 15. Now if I'm going to rearrange it, I'm going to have to do that in the opposite order. I'm going to have to deal with the addition first and then the multiplication, going through BIDMAS backwards. So rather than adding on u to at, I'm going to subtract it. So I'm going to start off by doing the opposite of adding u, which is subtracting u from both sides. Okay, that's going to give me v minus u on the left. On the right hand side, those two things cancel, and it's going to leave me with a t. Okay, so now I've dealt with the addition. The next thing to do is to deal with the multiplication. So the opposite of multiplying is dividing. So I'm going to divide both sides by t to get a by itself. So I'm going to divide by t, divide by t. So those t's are going to cancel out, leave me with a there, and I'm going to get v minus u divided by t. Okay, just going to spin it around. So a is actually at the start of the equation, start of the formula. So a equals v minus u over t. Okay, Students often wonder why I write my V's like that with a little kind of tail at the top. And it's just really to distinguish between U's and V's. When you do a lot of maths, V's and U's crop up a lot. So yeah, it's just a way of making sure your V's look different from your U's. Choose a word from the list that best describes each statement. We've got identity, expression, formula, term, and equation. Okay. Now this first one here has got an equal sign in it, so I'm guessing that is the equation, isn't it? So I'm going to write down equation here. It's an equation in N. Right, now the next one, I've got two things added together. Now each one of those two things, like that and that, those two things are called terms. So if we only had one of them, like 3x or 2y, it would be a term. But because we got them added together, we've got what we call an expression. So an expression is made up of various terms combined together. But expression doesn't have an equal sign, so you can see the first one had an equal sign, so that makes it an equation. No equal sign, it must be an expression. Right, now just a slight caveat. Now this one here at the end also has an equal sign. You might be thinking it might be an equation, but it isn't. This is an example of an identity. Okay, now the reason why it's an identity and not an equation is that equations are only true for some values. So for instance, 8 equals n plus 2. Now that is true when n is 6. 6 plus 2 is 8. Okay, so when n is 6, 8 equals n plus 2, and that equation is true. But if n had any other value, it wouldn't be true. If n was 3, then 3 plus 2 is not 8. Okay, so equations tend to work for 1 or 2 or some values of your unknown. But an identity is different. It actually works for any values. Okay, now in this case, a plus b times a minus b, it doesn't matter what the value of a or b is, this is always true. Okay, a could be 10, 100, a million, 0, 52.6 or pi, it doesn't really matter. If you multiply it out like that, you're going to get a squared minus b squared always. Often we show these not just with a like a normal equation equal sign like that. We tend to draw them like that with 3 lines, but they didn't write in there because they tried to make it a little bit harder for you to spot, but actually it's an identity. Question 14. Harry's paid £8.60 per hour for the first 30 hours he works each week. After 30 hours, he's paid at 1.5 times his hourly rate. Last week, Harry worked 33 hours. He was also paid a bonus of 1/10 of his earnings for that week. Calculate how much Harry was paid in total last week. Okay, so I'm going to do this in parts. He is going to get his basic pay, isn't he, of his base 30 hours at £8.60. Okay, so that's his kind of basic normal pay. 30 times £8.60, that comes out to be £258. 258. Okay, then I'm guessing this is what we call overtime. It's an overtime rate, isn't it? Okay, where he gets paid 1.5 times his hourly rate. Okay, so he is working the difference then between 30 and 33. That means he's working 3 overtime hours. Now he's going to get an overtime rate of 1.5. So I'm going to multiply that, but I'm just going to write it as a decimal because it's going to be easy to type into the calculator. 1.5, and then I'm going to times it by the hourly rate. Okay, so 3 times 1.5 times 8.6. So 3 times 1.5 times 8.6, that comes out to be £38.70. Don't forget money, 2 digits. Don't just write down 0.7. And then finally he gets paid a bonus of 1/10 of his earnings of the week. Okay, now 1/10 as a decimal is just 0.1. You could just write it as a fraction, 1/10 if you wanted to. So 0.1 times his earnings for the week. So what has he earned so far? He's earned 258 plus £38.70 then, isn't he? So what's that then? So if I add on 258 to my previous answer, that means you earn £296.70. And I'm going to times that by, now just thinking about it, if I times it by 0.1, I would get the bonus amount, and I'd then need to add it on to the original amount. But I think if I just times it by 1.1 instead, that would be better, wouldn't it? Because it's basically 1 and 1/10. 1 and 1/10 is 11/10, which is 1.1. So if I multiply it by 1.1 instead, 1.1, I'll just do it in one step. Okay, so that comes out to be 326.37. Just notice I've gone off the page a little bit. Let's just bring it over a little bit. Now, if that confused you, then you could just find 10% and or like a tenth of it and add it on. I'm a bit lazy, so if I can do it in one go rather than two, I will. Okay, so that's my answer. Total is £326.37. 15a, we've got some more rearranging to do here. We want to make x, or find x. So again, going through BIDMAS backwards, I'm going to deal with the plus 5 first. Subtracting 5 from both sides. That's going to leave me with x over 2, because that's going to cancel with that. And then 15 take away 5 is 10. Okay, and then the opposite of dividing by 2, times in both sides by 2. That will cancel with that, leaving me with just x. X equals 10 times 2 is 20. X is 20. Okay. Now part B says factorized 5a squared minus 10a. Okay. Now just take care here, because there's actually more than one factor. Factors are numbers that divide into both terms. You can see I've got 5 and 10. 5 has factors 1 and 5, 10 has factors 1, 5, and 10. So the common factor is going to be 5, so I'm going to bring 5 out of the bracket. Okay, but you've also got a squared and a, so a is also part of both terms. So I'm going to factorize out 5a. 5a times a is 5a squared, and 5a times 2 is 10a. So the factorized form is going to be 5a lots of a minus 2. Okay, so basically what goes outside the brackets is the thing that is common to both terms, and what goes inside the brackets is what's different about both terms. Finally, we've got a quadratic to factorize, x squared plus 15x plus 56. Okay, so I tend to start with the number on the end, the 56, and I would be looking for all the factor pairs of 56. What are the factor pairs of 56? I've got 1 and 56. 2, yes, an even number. 2, 56 divided by 2, that's 28. Does 3 go into 56? No. Does 4 go into 56? Yes, it does. 4 and 4 times what is 56? That's going to be 4 and 14. 5, no. 6, does 6 go into 56? Nope. The 7. Yes, 7 eighths of 56, aren't they? And I've kind of met myself coming back down the other way because there's no numbers between 7 and 8. Right, so they're all the factor pairs of 56. Now, one of those pairs is going to add up to 15. Which pair is it? It's going to be this number on the end, isn't it? 7 and 8. Okay, so they must be my numbers. Okay, so I'm going to get x and 7 and 8 and plus and plus. Okay, so x plus 7 times x plus 8 is equal to 0. So 7 times 8 is 56 and 7 plus 8 is 15. So it kind of all matches up. Okay, but we need to solve for x here. So what values of x make this expression 0? Well, if x was negative 7, if I added 7 to it, I'd get 0, and 0 times anything is 0. So that's one solution. Or x is minus 8. So negative 7, negative 8 are my solutions. Question 16. The height h of a lorry is 4.3 meters, correct to 1 decimal place. Complete the error interval for the height h. Okay, Now I like to do these with the number line. I draw a number line and I mark on the number that they've given me, which is 4.3. Okay, so then we know it's correct to one decimal place. If I was drawing a scale and that was going up in numbers to one decimal place, then the next one up on the scale would be 4.4, and the one below it would be 4.2, wouldn't it? It'd be 4.2, 4.3, 4.4. Now, the numbers that round to 4.3 are going to be the numbers that are halfway between 42 and 43 or nearer, or halfway between 43 and 44 or nearer. So basically, this range of numbers are the numbers that round to 43, aren't they? Okay? But what number is halfway between 42 and 43? Well, I know that that is not 42 and 43, 4.2 and 4.3. It's 4.25. If you're not sure, you could just add the two numbers together and divide by 2, and that would tell you on your calculator. And the other one then is going to be 4.35. That's halfway between 4.3 and 4.4, isn't it? Okay, so my lower bound is going to be 4.25 and my upper bound is going to be 4.35. So any numbers between 4.25 and 4.35 round off to 4.3 to one decimal place. Question 17. The table shows the number of barrels of oil produced per day by some countries. So we've got the USA, China, UK, Cameroon and Japan. And the barrels of oil produced per day, they've each been given in standard form, haven't they? So you've got a number times 10 to the power of something. Now it says write the number of barrels of oil produced per day by Cameroon as an ordinary number. Okay, so I've got in standard form 9.32 times 10 to the 4. So 9.32 times 10 to the 4. What's that then? 10 to the 4. Well, there's different ways of doing this. You can think of 10 to the 4 as a 1 followed by 4 zeros. And just do it on your calculator. You can just type 9.32 times 10,000. Or the other way of doing it is just taking 9.32 and kind of moving the decimal point 1, 2, 3, 4 jumps along, and then backfilling with zeros. Okay, either way, you should end up with 93200 as your answer. Okay. How many more barrels of oil per day did China produce than the UK? Well, how many more? That's the difference, isn't it? So that's taking one number away from the other. So if we take the China number, 3.98 times 10 to the 6, and I subtract the UK number, which is 9.39 times 10 to the 5. I can actually do that on my calculator. I think I will. So on my calculator, if I type in 3.98 and then press this key here, you see it's already got times 10 to the x written on it. So press that and then type in the exponent, which is 6. So 3.98 times 10 to the 6, subtract, I'm going to type in the 9.39, hit the exponent button, and then type in the power, which is 5. It's just going to tell me the answer straight off, 3041000. I'm just going to write that down, 3041000. Okay, but it says give it in standard form correct to 3 significant figures. Okay, so that means I need to round it off first to 3 significant figures, which is going to be 304. It's going to round down, isn't it, and 4 zeros. So it's that, and then as a number in standard form, I'm going to have to put a decimal point between the 3 and the 0. Okay, and the decimal point has moved 1, 2, 3, 4, 5, 6 jumps back, isn't it? So it's going to be times 10 to the power of 6. So it's 3.04 times 10 to the 6 more barrels, which is quite a lot. Part C says Jamal says USA produced approximately 3 times more barrels of oil than Japan. Is he correct? Show how you decide. Well, clearly not. The USA has got 1.17 times 10 to the 7 barrels. 1.17 17 times 10 to the 7. Now 10 to the 6 is millions, and 10 to the 7 is tens of millions. So that's going to be like 11,700,000 barrels. Okay, whereas Japan, 3.92 times 10 to the 3, 3.92 times 10 to the 3, that's only a fraction, isn't it? That's going to be 10 to the 3 is thousands, so it's going to be 3920. It's nowhere near. Okay. So how many times bigger is the first one? So if we divide one by the other, if I take like, if I divide those, so 11,700,000 divided by 3,920, that comes out to be, well, it's basically 3,000, so it's approximately, well, let's just write it down. So it's 298, well, I'm just going to round it off to 5, so 2,985. Okay, so Jamal is wrong because USA produces around 3,000 times more oil. Question 18. A triangle has sides of length 14.1 centimeters, 14.8 centimeters, and 19.5 centimeters. Is this a right angled triangle? Show how you decide. Now, I'm going to do this using Pythagoras Theorem, actually. Okay, now you should know that if you've got a right angled triangle where the long side is C and the other two sides are A and B, okay, then if it's a right angled triangle, then C squared equals A squared plus B squared. Okay, so if it's a right angled triangle, then Pythagoras Theorem states that the square root of the hypotenuse equals the sum of the square of the other two sides. But it's a two-way street, this thing. So you can say, if it's a right angled triangle, then Pythagoras Theorem holds. But you can also say it the other way around. You can say, well, if Pythagoras Theorem holds, then it must be a right angled triangle. So you can use this as a bit of a proof about whether a triangle is right angled or not. So what we're going to do is we're going to take the three sides and see if it works in Pythagoras Theorem. Okay, now my long side here is this one here, isn't it? 19.5. So that's going to have to be C. So C equals 19.5. And then I've got my two shorter sides, 14 and 14.1 and 14.8. So 14.1 is going to have to be this one. 14.8 is going to be this one. So this one is 14.1 and this one is going to be 14.8. Okay, so let's sub those into Pythagoras Theorem. So 19.5 squared, is that equal to 14.1 squared plus 14.8 squared? Let's find out. So 19.5 all squared, that comes out, according back to my calculator, as 380.25. Is that equal to 14.1 squared plus 14.8 squared? No, it's not. That comes out to be 417.85. So these two things are not equal to each other. Okay, so I can now say that no, it's not a right angled triangle because Pythagoras Theorem does not hold. And I might just say that C squared is not equal to A squared plus B squared. Okay, so it can't be. So if it's a right angled triangle, Pythagoras Theorem holds. If Pythagoras Theorem doesn't hold, then it cannot be a right angled triangle. QED. Question 19. One morning, Kai records the colour of cars passing his house. He then works out the relative frequency of each colour. Some of his results are shown in the table below. So we've got silver, which is blankety blank, and then we've got red, green, black, and other that we do know. Now the following morning, Kai is going to record the colour of the first 200 cars to pass his house, work out an estimate for the total number of cars coloured silver or red that he should expect to see. Okay. Well, first off, I can use the law of completion, which says that all of these relative frequencies need to add up to 1, then, don't they? Okay. So my value for silver, let's just call it x for now. X plus the others, 0.16 plus the 0.10 plus the 0.24 plus the 0.32, that should all add up to 1, shouldn't it? Okay, so what do they all add up to? So 0.16 plus 0.1 plus 0.24 plus 0.32, that comes to 0.82. So I've got x plus 0.82, and that's equal to 1. So taking 0.82 away from both sides, that's going to tell me that x is going to be 0.18 then, isn't it? So that value there then, 0.18. Okay, once I know that, then it's very easy to work out expected silver. It's just simply number of trials multiplied by relative frequency. Okay, so there are 200 trials altogether, 200 cars passing the house, and the relative frequency 0.18. So multiply those two together. That comes out to be 36. Okay, and then expected red cars, it's going to just be 200 times by 0.16, which is going to be 32 cars. James has taken 3 examination papers in Spanish. Here are his first 2 results. So in paper 1 he got 43 out of 80. In paper 2 he got 38 out of 65. Paper 3 is out of 95. The marks in each of the 3 papers are added together. Find the lowest mark that James needs in paper 3 to achieve 60% of the total marks. Okay, well, let's start up by finding out what the total marks are. So we've got a paper out of 80, a paper out of 65, and 1 out of 95 then. So total marks available then. What's that? That's going to be those 3 amounts added together, which comes to, what's that then? 80, 145, 150, 100, 240. So out of 240 marks altogether. Okay, so what we then need to do is find out what 60% of the total marks is. So 60% of total marks. We're going to get that by taking the total marks then and finding 60% of it. 60% is 0.6, isn't it, as a multiplier. So 240 times 0.6, 240 times 0.6, that comes out to be 144. So it needs 144 marks in total then to get 6% overall. So therefore the marks required then are going to be that 144 minus the 2 scores he got in the other papers. He got 43 in paper 1 and 38 in paper 2. So adding those 2 marks together and taking it away from 144, so minus 43 plus 38, that comes to 63. So he's going to have to do pretty well on the last paper then to pull it off. 63 out of the 95 marks. So James requires 63 marks. 3 people take 2.5 hours to deliver leaflets to 270 houses. Assuming all people deliver leaflets at the same rate, how long will it take 5 people to deliver leaflets to 405 houses? Give your answers in hours and minutes. Okay, so we can use this first bit of information here to work out how many leaflets per hour one person can deliver. Okay, because if I know that 3 people take 2.5 hours to deliver 270 houses, then altogether that's 3 lots of 2.5 hours, isn't it? So it takes them 3 lots of 2.5 hours to deliver all of those papers. So that's like 7.5 hours, isn't it? So it takes 7.5 hours to deliver 270 houses. So how many can they do in an hour then? So if I take 270 and divide it by that, okay, 270 divided by that 7.5, that's going to tell me leaflets per hour that one person can deliver. So leaflets per hour per person, that's going to be 270 divided by 3 times by 2.5. So 270 divided by 3 times 2.5 comes out to be 36. So one person can deliver 36 leaflets per hour. Leaflets per hour. I think we're going to make that one person. So one person can deliver 36 leaflets per hour. Okay, right. So then for the second situation, we've got 5 people and they need to deliver 405 houses, and we want to know how long it takes. So time taken for the second situation, take our 405 houses, divide it by 36. We also want to divide by 5 as well, because there are 5 people delivering them, isn't it? So it's going to take a 50th the amount of time that one person does. So it's going to be 405 divided by 36 divided by 5. That comes out to be 2.25. So that's 2.25 hours. Now if we press the kind of the degree, minutes and seconds button, that converts it into hours and minutes. Did you know that? So that's 2 hours and 15 minutes. So that is equal to 2 hours and 15 minutes. Question 22. This graph shows part of a straight line. Write down the y-intercept. Now the y-intercept is the point where the line crosses the y-axis. So this is the y-axis going this way. So the point where it crosses is going to be here. Okay, so that's going to be at 3 then, isn't it? Write down the y-intercept. C equals 3. So we tend to use C for y-intercept. Y equals mx plus c, if you remember. So the y-intercept then is that number on the end. Okay. Show that the gradient of the line is -2. Well, the gradient m is y2 minus y1 divided by x2 minus x1, where you can just pick any 2 points really. I'm gonna pick that one there, this point here. Let's say this is the point 0, 3. So that is my x1 and y1. And then if I pick another point, doesn't really matter where it is. Let's pick that one down there. That is the point 3 minus 3. Okay, so that's going to be my x2, y2 values. So subbing those into the formula then, y2 is this number here, it's -3. So that's -3 minus y1. Where's y1? y1 is here, -3. So -3 minus 3 divided by x2. x2 is this one down here, so that's 3 minus x1. Where's x1? X1 is up here, is there. So x1 is 0. Okay, so I've got -3 take away 3, which is -6, divided by 3 take away 0, which is 3. That is, well, that's -2 as we said. So m is -2. The line continues to the right. Will the line pass through the point 50 minus 103. Show how you decide. Oh, no, sorry, I missed one out. It says write down the equation of the line. Well, using y equals mx plus c, y equals m, which is negative 2, x plus c, which we worked out to be 3. So y equals minus 2x plus 3. Okay, so the line continues to the right. Will the line pass through 50 minus 103? Okay, so the way we can do that is we can just sub into our values. So if x equals 50 and y equals minus 103, if we sub that into the equation, if it's true, then it lies on the line. If it's not true, it doesn't lie on the line. Okay, so if I put minus 103 where the y is, and that's equal to negative 2 lots of 50, so subbing in the minus 103 and the 50 plus 3, what's that then? So that's negative 103 on the left. On the right, I've got negative 2 lots of 50, that's negative 100. If I add 3 to it, though, it's not going to be negative 103, it's actually going to be negative 97. Okay, so these two things do not equal each other, and therefore it doesn't lie on the line. So no, because of the maths I've just done. I'm just going to say C calculation because I've already shown it. I don't have to write it down again. I've done it already. ABCD is a quadrilateral, and we need to construct a bisector of angle ABC. Now that's A, that's B, that's C. So ABC is this angle here. So in order to do an angle bisector, we need to put the compass in at the point where we want to create the bisector and draw two arcs, one crossing each of the lines that that the angle is between. Okay, and it doesn't matter how long the aperture is, it just needs to be the same. Okay, and then what you want to do is move your compass point to those two marks that you made and draw a second set of arcs between your two lines. And what you'll find is it creates this cross shape here. Okay, just to double check that didn't move. Yeah, it looks good. Okay, so once we've got that little cross, then we just bring out our ruler and draw a line from B through the center of the cross that we made. Okay, so that's my angle bisector of ABC. Okay. So part B says construct the perpendicular bisector of BC and show your construction lines. So here's BC. Again, it doesn't matter how wide we set our aperture, it just needs to be a little bit beyond halfway. That's optimal. And then we're going to draw two arcs again, one from C and one from B. And again, these will kind of form 2 points of intersection in between. There and there. Okay, and then our perpendicular bisector is going to be the line that goes through those two crosses. Okay. Now finally it says shade the region which is nearer to BC than to AB. So BC is here, AB is here, so we want it to be closer to this line. In other words, it's going to be above this angle bisector in here, isn't it? It's going to be this area in here. Okay. Now it also needs to be closer to B than to C. So it's this area in here to the left of the perpendicular bisector and above the angle bisector. Okay. Now, make sure you leave all these construction marks on. Don't rub those out. The examiners are looking for them. And if they don't see those construction marks, even if you have the lines in the right place, they're not going to give you credit. Lily buys and sells microwaves. She buys each one for £32 and sells it for £60. She also pays £7 for the delivery of each microwave she sells. If she sells a microwave that is faulty, then Lily must pay for its repair and redelivery. This costs her another £25 for each faulty microwave. Last month, 6 out of 80 microwaves Lily sold were faulty. This month she has orders for 133 microwaves. Calculate her expected percentage profit on the monthly order. Showing your work in the boxes below may help you present your work. Okay, so you don't have to do it in the boxes, but I think it's going to give a little bit of structure to your work, so that might as well make use of them. Okay, I would tend to do this anyway, even if they didn't give me the boxes. I kind of divide up my page a bit like this, and then work out each one of these separately, probably. Let's start top left. Expected number of 40 microwaves. Last month, 6 out of 80 microwaves were 40. Okay, so we're expecting 6/80ths to be 40 if it's of a similar thing as last month then. Okay, so we're expecting 6/80 multiplied by this month's sales. So this month she's sold 133, and I'm going to just use the same fraction as last month to get an estimate of how many I think are going to be 40 this time. So 6 divided by 80 and then times by 133. Now that comes out to be 9.975. I'm going to round that up to 10, okay? Because I can't have 9.940 microwaves. They're either 40 or they're not, and 9.9 is spookily close to 10. So I'm just going to keep it to 10. Okay, so there are 10. I'm expecting there to be roughly 10 microwaves that are 40. Okay, now income from sales, that's pretty easy. I've got orders for 133 microwaves. She buys each one for £32 and sells it for £60. She also pays £7 for the delivery of each microwave she sells. Okay, but for income, it's just the number of microwaves that she has sold times by the amount that she's getting for each sale. So it's just 133 times 60, isn't it, for now? So 133 times 60, that means she's got £7,980 coming in just in sales. Okay, so that's her sales. What are her expected costs? Well, she's going to have, for each sale of 133 sales, we expect her to, well, she needs to buy the microwave, which is £32, plus she needs to deliver it, which is £7. So that's those costs are for each of the 133 microwaves, isn't it? So what's that then? 133 times 39 essentially then, isn't it? 133 times 39. That comes to be 5,187. Okay, but that's the cost of the microwaves. But we also need to work out the costs of dealing with the 40 microwave. So the cost of 40 microwaves, I needed 2 extra boxes here, didn't I? I needed separate boxes for these two things really. So the 40 microwaves, of which we've got 10, if she sells a microwave that is 40, then Lily must pay for the repair and redelivery. This costs her another £25 for each 40 microwaves. So that's going to be the 10 40 ones times the £25 it costs her for each. That comes out to be 250. So then the total costs are going to be those two amounts added together. So the 5,187 plus the 250 plus 250, that comes to 5,437. Okay, so that's how much it's costing her. So then what we want is the expected percentage profit then is going to be your income divided by your costs. Okay, income over costs. So that's going to be 7,980 divided by 5,437. So 7,980 divided by 5,437. That comes out to be 1.467. So I'm going to just round that off to 1.468, which as a percentage would be 146.8% then, wouldn't it? Okay, so then what is the percentage profit your profit is going to be the percentage above 100%. Okay, so the profit is going to be 46.8%. The diagram shows Jane's lawn. It is the shape of a square of side 36 meters and 3 semicircles. She is going to spread fertilizer on the lawn at a rate of 30 grams per square meter. The fertilizer is only sold in 10 kg bags costing £15.80 each. Calculate the cost of the buying of the bags of fertilizer for her lawn. You must show all your work in. Okay, so there is lots to do here. Let's start off with how much lawn she has. Okay, so let's try and work out what the amount of square meters she has to fertilize first. So we're told that the square part of her lawn is 36 meters then, isn't it? Okay, so the shape of the square of side 36. So that means that is 36 in from there to there then, isn't it? Okay, so then what's the area then of the square part of the lawn? Well, we just saw earlier that the square is L squared, isn't it? So that's 36 squared. So what's that then? 36 squared. 36 times 36 comes out to be 1,296. 1296. Okay, so that is the square part. Let's work out the area now of each of the semicircles. So one semicircle then is going to be, well, it's half a circle, isn't it? So it's going to be half pi r squared, okay, which is a half of times pi. What's the radius? Radius is half of the diameter, so the diameter is going to be 36, is the same as the side of the square, isn't it? So half of that is 18. So it's going to be 18 squared then. Okay, so it's going to be half of 18 squared lots of pi. So 18 squared divided by 2, that's 162 pi. 162 pi. I'm just going to leave it like that for now because I'm going to shove it in another calculation in a minute. Okay, so then the total area is going to be the area of the square, which is 1296, plus 3 lots of 162 pi then, isn't it? Okay, so I'm going to actually work it out now. So 1296 plus 3 times 162 lots of pi. That comes out to be 2822.81. Just going to round off to 4 significant figures for now because I want to drop down to 3 later probably. So let's just round it off to 2823. 2823 meters squared then. Okay, so that's the area of her lawn combined. Okay, right, so we're making progress. Now the next bit says she's going to spread fertilizer on the lawn at a rate of 30 grams per square meter. So how much fertilizer required then? What is the fertilizer required? Is going to be the amount of lawn she's got, 2823, times the amount of fertilizer she needs per square meter, which is 30 then, isn't it? So multiplying those together will tell you how many grams of fertilizer she needs. So times that by 30, that comes out to be 84684 grams. Okay, now we're told that the fertilizer is only sold in 10 kg bags. Okay, so how many 10 kg bags is she going to need? Well, let's convert that grams into kilograms first. Now there are 1,000 grams in a kilogram, aren't there? 1,000 grams is 1 kg. So to convert that number of grams into kilograms, I'm going to have to divide by 1,000. Okay, in other words, I'm going to have to put a decimal point in, about there. 684 there. So it's 84.684 kilograms. Okay. Right, now she cannot buy 4 kilogram bag because they only come in 10 kilograms. So how many 10 kilogram bags is she going to have to buy? She's going to have to buy 9, isn't she? Because 8 is not enough. That's only 80 kilograms. 9 is a little bit more than she needs, but 9 is what she's going to have to buy. So she requires 9 lots of 10 kg bags. Okay, so she needs 9 of them. So the cost of those 9 10 kg kilogram bags is going to be 9 lots of £15.80, isn't it? Because they each cost £15.80 each. So multiplying 9 by £15.80, 9 times £15.80, that comes out to be £142.20. 142.20. So calculate the cost of buying the bags of fertilizer for our lawn. It's £142.20. You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again next time.